Hi everybody, very welcome to Mentour and yet another video podcast. As always, I hope you're all doing fantastic. Thank you very much for joining me on the podcast. Today we are going to talk about Category 3 ILS approaches and autoland. This is something that I have had quite a few questions about, guys, so I'm going to try to answer all of those questions in this podcast. And as always, if you have more questions about this, then feel free to enter them into the comment section after, and I will try to answer them as to the best of my capability. Right, so in order to talk about Category 3 ILS approaches, you need to know a little bit about what they are and when we do them, why we do them, why they're not done all the time, things like that. So that's what I'm going to be explaining to you. So stay tuned, it's going to be quite interesting. A Category 3 ILS approach is an ILS approach where the aircraft is allowed to descend to a decision height of approximately 50 feet. Normally it is 50 feet, it can be slightly higher than 50 feet. When you do your instrument rating, you will be certified to fly a Category 1 ILS approach, which will take you down to a decision height of approximately 200 feet above ground. So in other words, a Category 3 ILS approach is something you would do when you need to get closer to the runway, which would indicate that it's because of low visibility. Right, so that's really the only reason we do Category 3 ILS approaches is when it's really, really foggy outside. So generally speaking, the decision height, like I was mentioning, of a Cat 3 is 50 feet, and the RVR, runway visual range requirement, is 200 meters. So you can come in and do a Category 3 approach in really, really dense fog, and that's what the airlines are after, and that's what we're doing it. When we are doing Category 3 approaches, the visibility is generally so bad that we do not have the capability, humans do not have the capability to actually do the approach and landing maneuver themselves. So a Category 3 ILS is flown and landed by the aircraft itself. This does not mean that you can land in complete fog, okay? You need to, at the minimums, which is at 50 feet, so just as you're crossing over the runway threshold, we need to have enough visual cues to establish whether the aircraft is going to land within the touchdown zone and on the center line or not. Right? So if we cannot determine that, we have to go around. But in my experience, Category 3 approaches will get you down in almost any kind of fog. If you are allowed to start the approach, you generally tend to land from them. It's very, very rare to go around from them unless you have some kind of system malfunction or if the fog is extremely dense. So Category 3 approach is an excellent tool that we, the airline pilots, have if the company is allowed or the runway is approved and the ILS is approved, and we, both of us, the pilots, are trained to do them. Right. So how do we fly a Category 3 ILS approach then? In this podcast, I will not go into much about the technical requirements. Okay, there's quite a few technical requirements on the aircraft itself that's needed for the aircraft to be Cat 3 approved. If you're interested in knowing what those system requirements are, then I would suggest that you Google just Category 3 ILS system requirements or something like that. Or if you're working for an airline already, your FCOM, your technical manual, will tell you exactly what you need to know. If you have system failures on board the aircraft, we have something called minimum equipment lists that you can go in and you can look at to see whether or not the system failure will have an effect on your on the Category 3 capability of the aircraft. The same goes to a certain extent for the QRH checklists if you do them. But as I said, I'm not going to go too deeply into that. I'm more going to focus on how we actually fly it and what you need to think about. So if you are going to do a Category 3 ILS approach, the first thing you're going to have to do is establish whether or not you're allowed to do it. And we do that with the help of a checklist that is situated inside of the QRH, the Quick Reference Handbook. So it's always going to be the first officer who is going to be flying the Category 3 approach. And it's always going to be the captain who is going to land it. Okay, and when I say captain is going to land it, I mean it's the aircraft is going to land it, but the captain who is going to be pilot flying in the landing maneuver. Well, I'll come to that later on. So what happens is that the first officer, if he or she is not already pilot flying, they will become pilot flying, and they will set up and brief for the ILS approach. And the first thing they will do is they will take the QRH checklist up, and they will run through the specific checklist needed for the Category 3 ILS approach, which will ask, is the crew qualified? Is the aircraft qualified? Is the ILS and the airport qualified? And if all of those are okay, and then we can continue. Then there are a couple of other requirements. There's some weather requirements. So the RVR cannot be, the runway visual range, which is the visibility, cannot be less than 200 meters in order to start the approach. There's some wind requirements as well. You cannot have more than 25 knots of headwind, 20 knots of crosswind, or 10 knots of tailwind. And there shouldn't be any reported or forecasted wind shear or any moderate or above turbulence. So we check through that. If that's not the case, then we continue. After that, it is a setup and a brief, just like a normal ILS, except instead of setting the minima on barometric minima, which we normally do, which is we calculate the minima set in relation to the outside air pressure. In the case of a Category 3 ILS, we use our radio altimeters instead. So we set a decision height based on radio altimeters, and that's a little bit different than a Cat 1 ILS approach. In the case of Cat 3, that will almost always be 50 feet radio that we will set up. Then the first officer will do the briefing, point out any threats that is associated with a very low visibility approach, and he or she would pay particular attention to the taxiing phase after the approach is done, because to be perfectly honest, the biggest threats that we face during low visibility operations is when we're taxiing, because the taxiing phase you don't see much at all. If you have 200 meters RVR, you're going to see only the taxi line in front of you, and it'll be very hard to see any obstacles or to navigate. It might sound strange, but it's actually one of the more difficult parts of low visibility procedures. Then a normal briefing, and at the end of the briefing, and this is something that I recommend that you do, the first officer should point out what is different with this approach from a normal Cat 1 approach, and there are a few things that are different. So I'm not going to point them out now, but I'm going to show you what is different as they're starting to fly the approach. So as we're descending in, we're coming in towards the airport, the briefings and the descent and approach checklist have been completed. We will start taking flaps at a normal distance. So the rules in my particular airline states that we need to have at least flaps 1 at about 10 nautical miles away from the threshold. And when you're flying a Cat 3 approach, you tend to be a little bit more conservative. So you probably have flaps 1 and flaps 5 by 10 miles. Start reducing speed. When we are cleared for the approach by ATC, if you're on a radar vector, for example, as soon as we're on an intercept heading and we're cleared for the ILS approach, the first officer will arm approach mode, and I'm talking about Boeing here now, it might be different on an Airbus. He or she will arm approach mode, and then arm both Command B, which they would have been flying on already, and Command A, which is the second autopilot. So this is something that's slightly different. On a Cat 1 ILS, we would only fly with one autopilot. On a Category 3, 2 and 3 ILS, you need to have two autopilots, because they need to both monitor the aircraft path. So this is different. And it's also really important to remember to arm that second autopilot, because if the second autopilot is not armed as we're descending through 800 feet of radio altimeter, it cannot be armed. So if you've forgotten it up until that point, you cannot fly the Cat 3 approach, and you will have to go around. Right. So once you're clear for the approach, on the intercept heading, approach mode, Command B and A. Okay. After that, it is fairly normal procedures. We will get localizer capture, and the first officer will then set runway heading. Glide slope capture, we will set the missed approach altitude. And then we'll continue down the glide slope using the normal calls and procedures as we descend. Right. So up until here, it's not much of a difference. It's just that arming of the second autopilot. The Boeing 737 has what's called a fail passive system. What that means is that you have two autopilots talking to each other. Okay. and they are using the same ILS transmitters, the same ILS beams, both of them, to interpret how to maneuver the aircraft. Right. With a fail-passive system, if one of the autopilots would get some kind of malfunction, let's say both autopilots are saying, okay, we should be going straight ahead and we should be sending at this rate. And then all of a sudden, one of the autopilots says, no, actually, I'm going to turn left. The other autopilot will say, no, okay. And the autopilot that will control and make the smallest maneuver will continue to control the aircraft. So it will not change anything, it will not retrim, and both of them will then disconnect. Okay, that's a fail-passive system. So it will not make any big maneuver if one of the autopilot decides to do something crazy, but they will both disconnect, and obviously you will not be able to continue to fly the Cat 3 approach without the autopilot. But at this time now, if everything works like it should, both autopilots should be giving the same control inputs, flying down the approach. We'll be doing the same call-outs all the way down to 500 feet on the radio altimeter. Below 1,000 feet, well, basically to start off, from 2,500 feet, the radio altimeter becomes live. And you'll see that at the top right corner of your primary flight display. It will be a numeric figure down to 1,000 feet, and after 1,000 feet it will turn into a dial that will start counting down towards 0. When we pass 500 feet radio, the captain will start by calling out 500 feet radio and then verify that flare is armed on the flight mode annunciator, which is at the top of the PFD. So 500 feet radio, flare armed. The first officer should then respond with whatever he or she sees. So that might be 480 feet radio, flare armed. Really important that you verify that the flare is armed at that point, because if it's not, you will not be able to fly the Cat 3 approach. So below 500 feet, there's a couple of things that will happen that's different from a Category 1 ILS. For example, the aircraft is going to start to get itself ready for a flare or a go-around. And the way it does that is it starts trimming back. So you will see that the wheels, the trim wheels on the side of the throttle column is starting to trim back. And that's perfectly normal. The other thing that's happening is that the captain will start moving his or her hand down below the hand of the first officer. Remember, the first officer is flying the approach at this point. And the captain will start looking out. He or she, the captain, would probably sit just slightly higher than they would on a normal approach. And the reason for that is they want to get as little cockpit cutoff angle as possible. They want to see as much as possible. And if they're only sitting a centimeter too low, that's going to make a 10-meter difference in cockpit cutoff angle. So they're going to sit a little bit higher. They can elect if they want to have the landing lights on or off, depending on what the outside conditions are. But sometimes it's better to have them off because you'll get better contrast with the approach lights. But most of the time you'll have them on. So the captain is now sitting out, looking outside with his hand or her hand below the hand of the first officer, looking for any visual cues. And also, while he or she is doing that, they should be looking inside as well now and then, just to verify that there are no system malfunctions. Because if you have any kind of system malfunction below 500 feet, any one of them can call go around and just execute the go around. There's not going to be any discussion about it. It's just going to be a go around, because you need to be very, very careful when you're this close to the ground. The first officer, on the other hand, will be completely focused on the go around, because the first officer is going to fly the go around if that's the case, and the captain is going to do the landing. So the only thing the first officer have to think about is, okay, in case I get down to the minima and I don't hear anything, or I hear go around, I'm going to do this, just so that they're mentally prepared for the go around. Right? It's very important. So coming down towards the minima, you will hear plus 100, to which the pilot flying, which is the first officer, is going to respond, check. Very important to respond to all GPWS callouts throughout the maneuver, because it's all a incapacitation check, and you really don't want an incapacitation during a Cat 3 ILS approach. The captain can call anything he or she sees. So if they start to see the approach light, they can call that, but they do not take the controls. And this is very important, right? The captain can say approach lights, to which the first officer will not need to respond, but they can relax a little bit because they can kind of anticipate that the call is going to be land then. Possibly, it's still not sure. But at the minima, there needs to be a very clear call from the captain, either land or go around. If the call is land, the captain will physically remove the hand from the first officer, take over the controls, and concentrate on making sure that the aircraft is landing correctly. Okay. The aircraft is going to come down, and at 50 feet it's going to go into flare mode. So flare was white in the FMA before, it will turn green and it's going to start to do the flare. And at 27 feet approximately, the thrusts will start to retard. And then as the aircraft touches down, the captain will choose the reverses, and after nose gear touchdown, disconnect the autopilot and auto throttle, but the auto throttle will disconnect by itself after 2 seconds after landing, and then control the aircraft. So once the autopilot is disengaged, the captain is going to have to control the aircraft going down the center line. If the call is go around, the first officer will then execute the go around. And remember, this is at 50 feet, so this execution of the go around needs to be fairly swift because the aircraft will descend a little bit more as you start the go around maneuver. So if the captain then calls go around, the first officer will press toga, call go around, flaps 15, set go around thrusts. And since this maneuver is flown by the autopilot, the go around will be an automatic go around, providing that the systems are all working. So the only thing the first officer needs to do is make sure that the system response is correct. Toga, go around, flap 15, set go around thrust. The aircraft will start pitching up by itself. Captain selects flap 15 and make sure that the thrust goes up to the reduced go around thrust. And then as you start to get a positive rate, and you have to wait to positive rate because you're going to get down to maybe 10 feet above the ground. Sometimes if you're really heavy, the aircraft might actually touch the ground as part of the go around maneuver. It's perfectly okay. But when you get positive rate, then you can call, as a first officer, call gear up, to which the captain then verifies that it's positive rate and selects the gear up. Proceed up during the go-around maneuver at 400 feet, select a roll mode. Normal cases that will be LNAV or heading select, but LNAV most of the cases, and then start to retract the flaps. The system, the aircraft is going to start automatically accelerating the aircraft to the speed, the minimum maneuver speed for the actual flap setting at, and this is important, at maximum takeoff weight. So it will actually show you the minimum speed for the flap setting that you're at the moment, but since it's calculating for the maximum weight of the aircraft, it will look like it's bugging itself up. So that will enable the first officer to continue calling for the next flap step. So flaps 5, flaps 1, flaps up. All of this time the autopilot is flying the aircraft, providing that there's not been any kind of malfunction. So the aircrafts will continue to stay in 2 autopilots until we close in on the missed approach altitude. When the aircraft goes into what's called altitude acquire mode, it's going to start leveling off and go into altitude hold, and that's when the second autopilot, the second one that was engaged, is going to disconnect, and it's only going to be one flying the aircraft. Okay, that's how you do a Cat 3 approach and a Cat 3 go around. Okay, and as I said, it needs to be flown accurately. The call outs need to be accurate, and you need to be aware that this is an approach that you're going to do in very, very low visibility. So there are some threats, especially specifically in the taxiing phase later on. So guys, I hope that explains it. I hope that if you do have any questions on this, then provide them in the comment section. And thank you for your patience and your time for so on. I hope to see you again in my next podcast. Have a fantastic day, and I'll see you next time. Bye-bye.